Hello everyone, I am Ajay Sharma from Problem Solutions. Along with me, Nagesh. Today we will make you understand about top 10 things in NX. Let us start one by one. Number 10. Tool costing, the unpredictable challenge. Tool costing drives the business. Cost engineer didn't have the visibility to all the drivers that impact their purchasing. Few problems are like, do you know your best cost of your tooling, regardless if manufactured in-house or outside? How to get accurate and consistent mold tool calculation? How to manage cost pressure that we often get from OEM? Impact of that loss due to undercoat tooling cost, business loss because of overcoat, competitor may win the orders, no company standardization for quotation. This is the part how to get accurate tool cost for this injection molding part. I don't want overcoat or undercoat. Need long time to figure out all features for tool costing. It is hard to remember everything at the time of quotation. NX solution for tool costing, faster and more accurate tool calculation due to feature recognition for injection mold, seamless interaction between design and costing. During the cost calculation process, NX also gives you flexibility to apply your own experience to get better results. Use of team center product cost management improves the speed 2 times. More codes due to standardization. Calculation of tool cost in team center PCM requires geometrical information. Instead of entering values and features manually, it will open NX directly. We will extract all cost drivers information, product information, undercut, we can get the height, width and depth. We can get the ribs information, openings, where the part is open, and we can transfer all information to the TC product cost management, where they are used together with tool specification and hourly rates to calculate tool cost. CNC milling, CNC lathe, how much is the per hour rate? We can get accurate and faster tool cost. Number 9. Mold design initial phase challenges for mold designers. If a plastic part can be successfully molded is an important question the plastic part designer need to ask himself. There are some few problems dealing with complex data, how to access moldability and manufacturability of the plastic parts, define gate location, how to check the efficient gate location, increase confidence in design. The impact of these issues, spend a lot of time to check undercut, negative angle, positive angles, draft faces, critical to identify accurate draw direction. If part thickness not checked, it is hard to understand suitable gate location for gate balance. Challenge for designers to validate products, sharp corners, draft angle, undercut, core cavity areas, where we get the tiny objects, where is the sharp edges, moldability of the part, warping issue and sink mark. Next, model part of validation capabilities, check regions by which we can designer can get the information of draft angle, undercut areas and core areas, cavity areas. Using check wall thickness, we can get the visual feedback of thickness using color codes. Easy feel similar the way a material actually flows through a mold for the plastic part. Check regions, we can easily find out the cavity and core regions, parting lines. We can get the vertical faces, there is no draft, where part may stuck, and we can get the undercut. There are also using draft analysis, we can get the exact draw direction. Using wall thickness check, we can check the thickness on different locations, and using the color code, we can get the wall thickness of the part. Number 8. Tooling challenges for mold designers. The main problems are that how to create highly automated core cavity design, capture and reuse the proven design, how to use the standard parts, how to reduce the tool design errors. Impact of these problems spend a lot of time for core quality design using manual method. There are no standard for the using proven design and need to start from scratch for every new mold design. Seamless flow is not available, so designers cannot understand each other's design. Huge chances of tool design errors because there are no automation for mold design. If I want to create core and cavity for this part, what are the challenges for mold designer? Customer multi-CAD data. Sometimes we get the data from other CAD formats. Early supplier involvement, reduce the errors, reduce turnaround time, increase confidence in design. So there is a solution, highly automated tool design with NX mold wizard. This is suitable for blow molding, double molding, insert molding, die casting, and forging components. There is a step-by-step process. All process is well defined. It looks like that someone is looking over your shoulders and guiding you. This is the part I want to create core and cavity for this part. Very fast we can patch and we can design the parting lines. Automatically it will generate the parting line. Then we can create the parting surface and define the core and cavity. It will automatically create the core and cavity. After that, from the mold base library, we can call the mold base and we can assign channels automatically, and we can also apply the plugs in the plugs and connectors in the cooling channels, and then we can create automatically assembly drawings. Number 7. How to avoid molding defects. Major problems are like how to check part model feasibility, how to analyze the thickness of part models, control cooling rates and improve part quality, how to eliminate short and sink marks. The impact of these problems are like unable to get manufacturability of part and have to spend a lot of time to check. Part thickness area, more cooling is required to achieve higher quality. Easily determine manufacturing defects would occur in your design. Common plastic injection molding defects. Defects means rejection. Sink mark, weld line, short, warping issue, and not proper gauge distribution. NX mold flow capabilities. We get total 77 results like cooling time, material filling time, warpage, weld line, sink mark, and also it avoid the optimize gate location using the gate location advisor, cooling time indicator, sink mark indicator. Let us see how many results we can get. So now I want to see that which machine I need to use for this part. How much is the filling time? So part is filling, and also we can check the screw pressure, and also we can check the temperature, and we can generate the report. Automatically the report in the form of PPT, it will export process condition and all these rates, weld line, air traps, pressure, temperature, sink mark. Number 6.
Sheet metal design and manufacturing is not as easy as we think. There are a lot of problems while dealing with the sheet metal design and manufacturing. How to manage complexity due to the behavior of material at the time of bending or forming. How to deal with the complex techniques that are being used in the automotive and aerospace. Because of these problems, there is adverse impact on the final quality and the productivity. It's difficult to obtain the accurate part shape and the required dimensional accuracy. Misalignment of holes is one of the known problems. Larger the bending radius, larger is the spring back. Hence, the angle and bending head cannot be maintained to get the accurate final output. To address majority of the problems and overcome the adverse impacts, Siemens provides NX sheet metal. You can set the key parameters, those affect your final design. Neutral factor is one of the key factors that impact the final design. Likewise, there are many more parameters, those control the final quality of the sheet metal product. So this ensures the required quality of the final product. NX sheet metal is a powerful application that ensures a single environment for all the sheet metal designs, ensures the manufacturing driven design process, clear design analysis. You can import the solid model, convert it to sheet metal and further work on that part as a sheet metal. User defined materials along with the properties, exporting the flat patterns and many more. A process specific set of tools give the ease of creating the features as well as editing the existing features. Using those process specific tools, you can design the complex sheet metal component with ease, and the final component can be flattened by using the different options and can be exported to the industry standard formats.
Number 5. The major problem of sheet metal industry: how to develop blank shape of complex parts. Problems are like how to eliminate effort and time on costly physical tryouts, spend a lot of time to create reports, how to analyze where part will be break due to stress. Impact of these problems are like accurate blank shape not getting, so part quality is not good. Spend lot of time and multiple trials is required to check spring back. How to avoid breakage of parts and increase part life. Simple parts we can do the flat solid very easily. But while working with the complex shapes, the complex shape where the forming is there, we are unable to get blank shape. So the solution is flatten anything with NX. Flatten complex shape very quickly, 100% accuracy without lot of testing. Using this tool, you can get right product in the first time. Analyze stress and spring back immediately. Quickly see where thinning and deformation will occur based on your material. Work with any CAD source. The key benefit of this: save money on physical prototypes by using the built-in analysis tools, speed up design time and reduce time to market. I want to get the blank development and the spring back of this part. So it will automatically mesh the part and it will generate the flattened shape. And this is the stress, strain, and this is the spring back which would occur in this part. We can generate the report, and so you can perform any task using one step formability. Number 4.
Working with faceted data or imported point cloud data in CAD packages is not easy. The problems like how to handle more complex organic shapes, how to handle the scanned data, point cloud data imported from the other applications, how to design the complex shapes, optimized single part from the multiple parts. Because of all these problems, the designing of complex natural shapes by simulation driven design becomes impossible. Use of the non-analytic shapes, that is scanned data, is impossible for design and manufacturing. Working directly with scanned data without the need of reverse engineering is not possible. To address all these requirements, Siemens came up with the Convergent modeling techniques. Using Convergent modeling, you can deal with the imported data. You can repair the data if the data is not as required, and later the data repaired can be used for the downstream applications. The convergent modeling have ample capabilities. It's a system that allows you to deal with the faceted data and the imported point cloud data along with the other kind of data, that is surfaces and solids. Using convergent modeling, you can ensure the end-to-end workflow from scan data to the manufactured product. It's a single environment to deal with the multiple kind of data. Convergent modeling allows the company's full reverse engineering workflow support within the robust parametric modeling system, allows significant productivity as compared to the other applications. You can deal with natural shapes using different applications like reverse engineering, polygon modeling, locally created objects, or imported data and objects created from those. Convergent modeling addresses the requirement of the industry to deal with the scanned and faceted data with non-primitive natural shapes.
Number 3.
While automating the design, we face some problems like handling the required expressions amongst the available expressions. We have the question of identifying the logical names of the expressions, or there is a question of relating the parameters using formula or different conditional statements. We have to also think of how can I control the input types to the field so that those should be always as required. There is an impact on our productivity as we have to handle all the expressions separately. To customize the application to suit the designer's requirement is not possible, as programming knowledge is not the skill of a designer. Using part family will help to automate the requirements up to certain extent, but doesn't allow to create the required variants. We can handle easily the expressions if the number of expressions are less in the part, but if the number grows, then it will be a challenge to handle the expressions. This requirement can be easily addressed by using the product template studio in NX to address their automation requirement and improve the productivity by 90%. It is a designer level configurable application. A designer can create the dialog boxes and assign the names in the simple language to the parameters. Also, the input fields can be controlled. Once the template is defined, that can be very easily used by any user. The type of input fields are already defined, so no chance of entering the wrong value. The work can be quickly done. So if you think of improving the productivity drastically in your CAD environment, think of Product Template Studio in NX. The tool can improve the productivity by around 90%. That is really amazing. So think of Product Template Studio.
Number 2. Automatically create machine programs directly from part. Main problems are different people will machine differently, need standardization. Manual programming increase clicks and risk of errors because there are multiple holes. We can forget to machine any hole. Reduce programming and machining time. The impact of these problems: inconsistent process across the organization, which leads human errors. Low productivity due to lack of automation. Poor machining quality. I want to machine this part. There are multiple holes and pockets. So what are the challenges for CAM engineer? Spend more time to create program because we need to select multiple holes. Chances of human error. May forget to create program on any particular feature, any hole. Every CAM engineer using his own method. So there is no standardization process. Lot of time required to select the features. NX CAM capabilities using FBM reduce programming time by 90% with FBM because it automatically recognizes machining features like pockets, slots, holes, build the correct machining process from the library of operations, the rule based. It can work on PMI models data. Add new operations according your requirements. Key benefits: process automation, improve process quality, process and standardization. Mold parts have many holes, pockets, slots like ejector plate, which we need to machine fast. This is the ejector plate. I want to machine this using the FBM, so it will automatically recognize number 1.
To ensure the quality of final product, the manufacturers face many problems. How to verify whether the proper information is captured in 3D model, how to determine whether the part design is cost efficient to be manufactured, is the quality of CAD model geometry sufficient to utilize for the downstream applications. It impacts the final CAD data that may not be accurate, reliable and shareable. The CAD data cannot be seamlessly captured, analyzed to qualify results. It is difficult to ensure model quality, standard adherence and manufacturability. Also, it is impossible to report and communicate quality data in a collaborative way. Let us see an example. Here we are making a fully constrained sketch under constraint by removing some of the constraints. As a best practice, to ensure the quality, all my sketches should be fully constrained. But accidentally, if there is any problem, I cannot find out the problem. To address such kind of requirements to ensure the quality, one can use NX checkmate. It has the ability to execute the conditions and find out the required results based on the conditions, so that you can take the corrective action and ensure the 100% quality at every stage of your product. Here we want to check whether all the sketches are fully constrained or not, but we have made 2 sketches under constraint, so let us see whether NX can find it out. Here it goes. NX identified the under constraint sketches, and the results can be analyzed in different ways. To ensure the 100% quality in the final product, think of checkmate in NX.
Please connect with us on our Problem Solutions India Facebook page, Twitter, LinkedIn, and also add this number to your WhatsApp. So send your name and company name, so we will add you to our broadcast list. You will get all updated information through WhatsApp. You can send any query to marketing.india@problem.com. Please visit Problem India training page to understand our best training offers.